Ah, so guys, welcome back to the new stream where we'll be going to again continue with our CUDA session where we left off yesterday. We are live. Uh, nice. We have internet speed of 101 Mbps, megabits per second. Yeah, and this is the thing. Let's learn CUDA from where we left off. I have this statistics of my RTX 3050, the mobile GPU of 35 watt which I have in my system. I'm drinking black coffee. So as you can see, my OBS is running few stuff on my GPU. There is a process. This is the process ID, and this is the process name dot slash OBS, which runs on my GPU. Uh, I guess there is something called like background noise cancellation stuff, which like is built on this deep recurrent neural network. The inference of that might be happening on my GPU, but I'm not sure of that. We'll check it out. So that's a little bit of distraction. Let's go to our stuff. So we were like cd code, lscd CUDA, clear lscd. So code dot and exit. So now we did open our VS Code. Yeah. Hmm. So before delving into anything else, uh, let me recap something what we did yesterday. We were trying to get a hang of this function, CUDA malloc. This is not like automatically managed thing like CUDA malloc managed. This one. Where is this function? This one. Yeah. So CUDA malloc managed was like supporting lazy loading and the transfer of data from GPU to CPU was like automatically done by the CUDA drivers. But this function CUDA malloc is not like that. You have to do everything sort of manually. Okay. I'm confused by this one. It takes a pointer to a pointer. Now, what does this mean? I was confused regarding that, and it throws you like what it throws you. So basically, you give it this function basically returns you a memory location inside the GPU, and the location of that GPU you store in a variable in your CPU. That's the idea. Do some testing. Hmm. Hmm. The pointer P. Have the pointer P. Now I want to print some data about it. So the first thing I want to print is I want to print uh, what's the value in P. Uh, Print that I need data type specifier as I'm using C. It will be percentage. What is this? Percentage P. Comma. Let's call it a PTR. So let's compile this and run. Uh, it will print me something. I changed this name because I thought maybe there is conflict if I like I have in this directory I have two executables. One is for CUDA t.cu. Another one I just did for t.c. So if the naming of the two executables is same, I don't know whether there is some conflict or not. So to be on the safer side, I just changed it to TC. Okay. So so what this does is it prints me a memory location. It's in hexadecimal as you can see. Okay. Let's try to do something. Let's try to print the same thing with a different data type specifier. Let's say it's star P, it's D, it's an let's say let's make it an unsigned integer or some signed integer. Okay. Let's make it a signed integer. Uh, I want to print the value stored here. Like it must be some random value, I guess. This one. And I also simply want to print this one. Mm, with the data type specifier, I want to just print the location. Let's see what I like that. I have to give a new line and three here. Six and four. Hmm, nice. So as you can see, I got three different values. One is the memory location of my pointer, not actually memory location of this variable, which is 2 bytes, but uh, the random memory location it stores. I don't know whether this memory location exists or not. I have no idea, but yeah. Then I try to dereference it and print. I get something which is a random value, garbage value, and I just print the only the pointer, which is supposed to store a memory address in hexadecimal. I try to typecast it into a integer type and print it, and I get this number. Okay. Now what I need to do is, I'm this is the memory location, right? This is PTR, and I want to print this ampersand of that. Yeah, this is it. Now this is it. Hmm. Now what I need to do is, I need to again it will be a memory location, no doubt. Typecast it into how you should typecast in that CUDA malloc. I have typecasted it into how we used to typecast in CUDA malloc. Um, yeah. Let's print these three different things and see what we get. Yeah. So yeah, this will make things clearer. So I declare a pointer variable of integer type. That means when I dereference the value stored in the memory location, it automatically my compiler considers it to be of integer type. So that's the entire point of this int thing. It only comes handy when we dereference this pointer variable, not while storing the memory location because it is only 2 bytes, whether it is char or int or anything, because it is storing the memory location. It only it is only useful when we dereference that value in the memory location. So yeah, so this is a random memory location. This PTR value is storing. I also don't know whether it is valid memory location or not, memory address or not, but this is something random. I'm like sure about it. It's a random, but it's valid or not, no idea. Then what this thing is? This thing is the address of the pointer variable where the 2 bytes is stored at this memory address. PTR variable, which is a pointer variable, is of 2 bytes. And what is the memory address of that 2 bytes? This is this location. Okay. And now when I do what? When I double dereference it, when I this thing I'm trying to understand what this exactly is. Mm, If I just put a single star and execute it, and I still get the same value. I double dereference it, I get the same value. So let's give it to LLM and try to talk with it. On this session, in this session, we are learning CUDA. Let's go to Gemini and how good it is. Uh, it should have directly gotten me into this page. Anyway, explain me what each line of this code is doing. I need to print another thing here. This line declares a variable this, which is a pointer type, is a pointer to an integer. Crucially, PTR is not initialized. That means it doesn't point to any specific memory location. It contains a garbage value. Now, whether the garbage value is a valid memory address or not, we'll get into that later. I get here this printf. This line prints the value of the pointer. %p is the format specifier for printing pointers. Then unpredictable. I guess it's not a valid memory address. It might be some seemingly random number. Okay. Now, just like we talked before, this gives me the memory address where the 2 byte is stored, memory address of the 2 byte, which is the like PTR basically. Now these two are the most important things to understand. This line is similar to line 2, but it casts the pointer PTR to a void star. So basically, before some variable, like variable can be a normal variable or a pointer variable, whatever it may be, you add a prefix to it. Basically, in this format, like inside parentheses, you write some type and star and something like that. So what you're basically trying to do is you're trying to typecast that variable. So that's the entire idea. So a void star is a generic pointer type, meaning that it can point to any data type. Okay. Okay. So basically, star means you're typecasting into a pointer type, and what is the like what data type the pointer should point at? It should be void type. That's what you are saying here. It's a pointer to a void type, which means the value in that memory location has no specific type. The cast itself does not change the underlying garbage value, and that's what we are seeing here. The cast itself does not change the underlying garbage value. The garbage value was allocated when I declared this pointer type variable. And when I typecast into a void type pointer or integer type pointer or anything I can typecast it into in this format, this does not change the garbage value. It was initially assigned when I declared the pointer variable. Okay. Now this thing is what is double star. This is the most complex line. It attempts to cast PTR variable to a void star star. A void star star is a pointer to a pointer to void. So double star means it's a pointer variable to another pointer. It's a second order pointer. I guess you can think of it like that. But when I pass, when I pass um, uh, memory address to CUDA malloc, I pass a pointer to a pointer, but not a pointer. Why? Okay, now I got the entire idea why you are not giving the memory location of the pointer. You are passing a pointer to a pointer. Why you are doing that here? Why you are doing it? Okay, let's think about this from first principles. You define a host PTR variable in your host, that means in your CPU, which is a pointer type. That means it will store a memory location, a memory address, which is of 2 bytes, pointing to an integer data type. So that's what this entire thing is about. Now, this 2 byte is stored in this location. This 2 byte is stored in this location. Now, you want to extract the value allocated in the memory of the GPU from this variable itself. Correct? Am I correct? Now, this thing will be hooked to the exact value. It may be 50 or 60 or 1 million. The value which will be stored in the memory inside GPU. Okay. So, so which means from the perspective of the GPU, what it is, from the perspective of the GPU, this variable must be a pointer to a pointer by dereferencing which you can extract the value out of it. We can think of it like this. I tell the GPU the memory location where my pointer is stored. That's what I tell. So that my GPU can go to this memory location inside my CPU and store the memory address of the GPU, what my GPU allocated. It might get a little bit fudgy, but that's what it is. I have my CPU, I have my GPU. I ask the GPU to allocate some bytes to me. Now GPU drivers allocate that much byte to me. Now how they allocate that byte? What they return me? They give me a valid memory address inside the GPU. Now I should tell them where you should deliver me this memory address. I give them a pointer which is defined in my CPU. So can they access the pointer variable itself? No, they need to know the memory location of my CPU where this pointer is stored. That's why I give them and host PTR. But why typecast into a pointer to a pointer? Because this is actually what it is. This thing is what? This thing is a memory location which stores another memory location which can be dereferenced to obtain the value. That's why it is a pointer to a pointer. Okay, that's why it is like that. So, so when you're using CUDA malloc managed, you don't need to do this explicit typecasting, I guess. I don't know whether you can do it or not. Maybe you can do it and it works fine. But as far as the syntax GPT gave us, there was no explicit pointer to a pointer typecasting in managed. It is there. It is there, I guess. So let's do some printing stuff and see how things are going on. Will it always write some CUDA? I want to extract the link where I'm sharing my screen. Studio this. If I go to content, live. This is the stream right now. I copy this up, go to my keep notes, and I just share it. We are typecasting it into a pointer to a pointer because conceptually it is like that. That is, post underscore ptr stores from the context of the GPU. Post ptr stores is a pointer which stores another pointer pointing to the mem address inside the GPU, uh, which in turn stores the value. Just tell me whether just tell me whether what I said is correct or not. No, no, it does not store another pointer inside the GPU. Post PTR is on CPU. It stores the address of the memory on the GPU. It is subtle but important distinction. I guess it got my context wrong. Anyway, let's go to CUDA and do something interesting. I have a pointer. Now this pointer is in my post device. Okay. Now let it be null type. Okay. So if I print this off using printf, uh, p pointer is always of type p, and I print post underscore ptr, it must print this p thing. Now compiler is nvcc, file is t.cu, the executable is uh, t, and I run this dot slash t. I get null. Okay. So the assignment is mostly correct. Okay. So let me go through what is happening here right now. I have a host PTR. It is a pointer variable which is residing inside my CPU. So let's say I want to allocate 4 byte. There is a size operator. I don't know what this thing is. There is this size operator. This is U, I guess. Unsigned integer size operator. I can use this post underscore PTR. It must store 2 bytes, I guess. It is 8 bytes. What the fuck? Okay. Modern day pointers are 8 bytes. Okay, you must use a long unsigned LU. Okay, we'll use that. Yeah. So it's a host pointer. which is of the size 8 bytes. Okay, great. Now let's say I have something called int status. So I want to allocate some memory because I have run CUDA underscore runtime dot h. I can use this function, this CUDA malloc. Now I want to give it the memory address of my host pointer, which is ampersand host underscore ptr, and I want to say this function how much space I want to allocate. I want to allocate, let's say 4 bytes because integer is of 4 bytes, right? If I type here integer and I go down, I comment this thing out, I run and compile the program, compile and run the program, I get 4, which makes sense. Int is 4 bytes, but this variable of pointer type is 8 bytes. I guess it's a 64-bit modern day compiler thing. Uh, but previously it was 2 bytes as far as I have read the past literature in C. Okay, now conceptually this is a pointer to a pointer. That means host PTR stores a memory address which is inside the GPU, which in turn stores my value. So I typecast it to a pointer type. Now yes, now I'll print the status code of my memory allocation. So it is status uh, of my memory allocation inside GPU, and it will be of D because it is what do you call that? It's integer and status. Now what I need to do is I want to print the memory address which CUDA malloc returned. How now where that memory address is stored? It is stored in host PTR. So that's where the memory address of the GPU, where the CUDA runtime has allocated me the space, is stored. Let's print it out. Uh, printer memory address. The highlighting is a bit like in delay. I don't understand why. Memory address of uh, the space allocated by CUDA malloc in my GPU. Now it is a pointer. So the format specified is percentage %p. I give a comma and it is host underscore ptr. Right? Nice. I have everything sorted out. Let's run the program. I got everything out. I need to print a new line here so that I can get some legibility around reading this. I don't have much to clear this up. Fuck yeah. I'm again making the same mistake. Yeah, now it's fine. I declare a pointer, I declare a variable pointer type. I attach the value null to it. I print the size of this pointer variable, which is 8 bytes. The status of the memory allocation inside GPU is 0, which means the memory got successfully allocated by my CUDA runtime. And this is the location inside the GPU which stores my 4 bytes. This is the location which stores my 4 bytes. Now, the beauty is if I try to dereference this value, I won't get anything because my host, not my device is GPU, my host does not know what this location is, where it exists, because this location exists inside my GPU or my device. Let's try to dereference it and see the segmentation error. Uh, Extracting the value inside post PTR. Um, if you try to extract this value, you won't get anything because the host has no access to this memory location. Yeah, I guess I'll get some nice error out there. Yep, there is a segmentation fault because my CPU does not know where this location exists. Nice. And I have allocated 4 bytes in my GPU. I have certain functions to know how many bytes are allocated. So the next question is, what is the function to know the memory usage of my uh, GPU in CUDA? There was some function which we came across yesterday when we're randomly generating the most useful functions among this. So I guess this is the function. It is CUDA mem get info that's available by free memory on GPU. I guess you can store a value in GPU right now. We have allocated the memory using CUDA malloc. Then we can sort of copy things between host and device using this function, which is CUDA mem copy. Not copy exactly, it is CPY, and another is CUDA mem set. We try to get a hang of these two functions right now. Uh, so, okay, what's the next function you should explore? How is this? CUDA free. I guess we can only like get the feedback from this function once I get the function to track the memory safe because 4 byte won't be visible here. I can't see 4 byte here anyway, so I need a more granular view of my memory usage using some function out of this. I want this function. Let's go to CUDA docs and see this CUDA docs. Oh fuck, there are so many functions out here. Uh, what was the function? It is like memory management for CUDA. It's CUDA get meminfo. Can you search it? I guess. Get mem. This CUDA mem. It's symbol. Okay, different modules out there. API synchronization behavior modules. This is not the right thing. I guess I need to just Google it up. Yeah. So these are the two arguments. This is exactly where I wanted to go because this is the official docs which shows me the params of this function. Like this is not reliable, it can hallucinate. This takes a pointer which is unsigned integer type, and it takes two pointers actually. One is free, another is total. You get the info, something like that. Returns in this respectively the free and total memory available for allocation by the device in bytes. You get the return in bytes. Okay, so I need to define two pointer variables to extract the memory usage in my GPU. Okay, let's go with this. We have two variables. Let's say, so what are the parameters it takes? It takes free and total. Okay, let's have two variables. It typecasts it into a pointer type. I don't know what it does. Does it typecast? Uh, no, it doesn't typecast. It's an unsigned this. So memory is anyway not signed. It's of unsigned type. Let's say something free and let it be this. And another is like total. What is the size of this? Like order of the parameters. First one is free. The next one is total. I don't know whether in C the default is positional argument or not, or keyword argument. No idea. So to be on the safe side, let's pass it in the same order. So first one is free. The second one is total. I call this function and I again store the status. I call CUDA get meminfo. CUDA mem get info, not CUDA get meminfo. CUDA mem get info. It's all in camel case. This let's change the variable and it not be shown. Free mem and it should be okay. Let's print the status. Status of getting mem info. It's an integer type, so format specified is percentage %d. I get to a new line. I print status. Okay. So then what I do is I dereference these two pointer variables to extract the data in it. So I printf to the free memory. It's let it be long unsigned lu slash n. I get it's like free memory. I need to dereference it to get the value, and I can also get the total available memory. The available memory. I'm writing this detailed print statement so that I do not get confused later on when I print a lot of things. It makes things really comprehensible. So that's the very reason I'm writing such detailed comments. Star, uh, I get total mem. Okay, so we are done with this. Let's see how it goes. It always returns in bytes. Compile this stuff. There is an error. Why? Okay, it's already declared before. It is silly mistake here. Yeah, It's a segmentation fault. I guess the program stopped running there. I have to comment this thing out and run it again. Okay. Okay. But I don't get to see the value. I can't see it. Why? Returns in this. Why I'm getting an error here? I'm getting an error. I have no idea. What this function returns, man? It's a CUDA error underscore p type. I guess it's a custom data type out there. Uh, okay. So this is actually the torch abstraction on top of it. We don't care about this right now. Hmm. Okay, I get this can be of help. So okay, it has done the same thing. It's an unsigned integer type. It is again an unsigned integer type. Okay. Ah, I need to pass the memory location to it. It should not be a pointer type. It should be actual. It should not be a pointer variable. It should be a normal variable of unsigned integer type, and I pass it the memory location. That's where my mistake is, I guess. So I guess it should be correct by now. Okay, that was the issue. I got this thing wrong. Uh, where is it? This this is the parameter it takes. It takes a pointer as the parameter. So that means I need to pass the memory location, not the pointer. So that's the mistake I was doing. Now I get the free memory information and the total memory information in my GPU in these two unsigned integer variables, and I print it out. Okay, no, no. So I can subtract these two things to get the consumed memory. Printf CUDA allocated memory. Uh, Again, it would be like unsigned integer type. Okay, so it's all total memory is always greater than the like how much memory is allocated. So it is total memory minus free memory. This should give me how much memory is allocated by the CUDA runtime. Yup. No, it's not getting printed. What the fuck? How can this be such a massive number? I must be done doing some mistake. Let's compute this manually. Control Shift C. Okay. Hmm. Fuck. I did something silly. I should subtract the free memory from the available memory. How can I get such a large number? Whereas I've allocated only 4 bytes. I don't understand this. I have allocated only 4 bytes by using CUDA malloc, but I'm getting such a large number. Okay, this is in bytes. Ah, okay. Let's divide it by 10 power 6. It's like of the order 3. This is 452 MB. Let's check it here. Is it 452 MB right now? It's 359 MB. How the disparities, from where this disparities originating? I've got no idea. We have to go through this step by step. Hmm. We can like hack this thing and ask GPT, but let's struggle with this for a moment and then I had to figure it out myself and see. Okay, so as of now, we are I got a hang of this CUDA malloc function, so I don't need to print these things up. So I declare a pointer of integer type and assign it null, like and point it towards null nothing using null keyword. And then I typecast it into a pointer to a pointer type and pass it to the CUDA malloc, which returns me a status, which means the memory is allocated. I also don't need to print this right now. Let's make it a bit clean. Yeah, but I should print the memory location of my GPU. The memory address of the space allocated by CUDA malloc in my GPU is this one. This is fine. Cut it up. These are unsigned integers which will store how much memory is free, how much memory is allocated to my GPU. Okay, we don't need to store this thing. The printf also returns me the number of characters. I never stored it anywhere and printed it. So I don't need to store the status returned by the CUDA memget info also. So I've cut it up. Now these are my stars. These are the things which I care about right now. Okay. Now I need to it's in byte. So I need to divide it by 1 million to get like megabytes, roughly. So I can actually divide it here only. 2, 3, 4, 5, 6. I guess we are done with this. Let's run an infinite while loop and check what is happening. And yeah, okay, let's go on. So it is 452 megabytes is getting used. Yeah, okay. I guess it's correct. Some like there is some memory overhead which you are not accounting. Like I have allocated 4 bytes, but this process is consuming like 32 maybe bytes, which is like roughly 25 or like north of 35 megabytes. Why this is happening? Hmm. Need to get a hang of this thing. This process is consuming 70 megabytes. Really? How? If I stop the process, the memory consumption is 359, and when this process begins, my memory consumption goes up to 431. So it is like around 70. Yes, it's right. It's 70 megabytes. It's in the order of 2 power something, not 10 power something. So it's like 1 megabyte is 1024 KB bytes. So it goes in the order of 2, like 2 power, not in the order of 10, like 10 power something. Okay. This तुमसे मोहब्बत हो गई है मुझे तो तुम पूछो। Okay, so 452. Let's make it more accurate. Let's make it more accurate. It goes in the order of 2. So mega is 6. So it is like 2 power 6. Mm, not 2 power 6. I guess it's so. Mm, mhm. I can input math function. Okay. Now I can divide it by 2 power something. Megabytes is how many bytes? And okay, a kilobyte is 1024 byte. So it is 2 power 10. Right? 2 power 10 is 1024. From kilo to go to mega, I need to find the exact memory usage. That's what my task is as of now. That's what I need to figure out. So, okay, 1 byte. From byte, you go to 2 power 10. That gives you a KB. Like this many bytes is 1 KIB. Now, 2 power 10 KIB must be 1 MIB. I guess that's the thing. That's the equation. 1024 times 1024. Yeah. Here you do 1000 times 1000. You get 10 power 6. It's 1024 times 1024, which is basically, so to go from like 1 maybe byte is how many byte? You like multiply. You simply multiply that. It's 2 power 10 times 2 power 10. It's 2 power 20, I guess. Yeah. So what's 2 power 20? Let's check it out in Python. Uh, Open Python. It's 2 power 20. Yeah, it's like 10 power 6. I guess both are almost same number of. Yeah, it's 2 power 20. So what I need to do is I need to use the power function and I do this. As simple as that. Now this will give me the exact value. My system is consuming. Why I'm getting error? Uh, I don't typecast it. Is that why I'm getting the error? Hmm. Okay, it can't be an unsigned integer, I guess. Okay. It gives a return. It returns a double type. Okay, let's do this with long double, and I guess it should be fine by now. No, again you get the issue with. I guess we need to type first it into upload or at int. I guess it will anyway. Yeah. Perfect. Yeah, we got the exact number. I'm so happy. Yes. So that's the relation between megabytes and maybe bytes. So it's a thing to understand. I should write it right now. Like it's the memory is actually considered in maybe bytes. Maybe bytes versus megabytes. One is 2 power 10, another is 10, like 10 power what it is. Like kilo is 1000, mega is 2 power something. Like 10 power 6. Yeah. This thing you must internalize. So it is 359 MIB. I run the process, and now my total memory consumption is 431 MIB. As you can see here, the exact number, it's 431 MIB, and this program specifically consumes 70 MIB. How to compute this, I don't know. Maybe I have to do some system calls to know how this particular process is consuming. We'll do that later on. Yeah, we have got some result. We have learned how to use three functions. Okay, let's create another section. Uh, functions explode. Functions explode. Okay, so here I keep a list of function which we are exploring. Like have explored in a fair amount, not entirety of it, but a fair amount of it. The first function is CUDA device synchronize. I use this in the beginning, like in the first thing I use this synchronize. Uh, the second function which we explored in CUDA is, I guess, this CUDA malloc managed, that one. We have not explored that in depth. We just executed that before CUDA malloc. But we explored CUDA malloc first in full depth, how it returns. Now I return this CUDA get mem info. So this is a function. CUDA mem get info, not get mem info. You just jumbled up the order of the things. So these are the three functions which we explored as of now. One is CUDA device synchronize. We'll get more into this, but yeah, like, what this? It takes two parameters. One is free and another is total. Takes two. Let's write a bit about it. Two params of point two pointers as params, two memory locations as params. Um, it is free. Uh, that is one is free, another is total. I guess that's one usually. It's one is free. Like what are the parameters? One is free memory. Another one is total memory. Okay. How free, and the next one is CUDA malloc takes two params, that is pointer to a pointer variable. Let's do some cleaning work. I have this pet tips. I don't know why. Two params, pointer to a pointer variable, and space to allocate, which is like unsigned integer. So size underscore it would be. This is the dish type. Like, size to allocate. Size to allocate. In bytes, of course. Bytes is the like SI unit sort of. Two memory locations as params. One is free and total. Both are pointers. Both are pointers during memory locations, memory addresses. I guess to do low-level programming, you need to be extremely comfortable with manipulation with memory location and pointer variables. Like this forms the staple of the entire low-level stuff. So how long we have been streaming, by the way? I'm curious. It's been 1 hour and it passed like that. That's fine actually. We are engrossed in what we are doing right now. Okay. So what other function I need to explore? We have like today we have explored CUDA malloc, CUDA memgetinfo, CUDA device synchronize. This one is complex in taking your time. This talk actually makes sense. This one. This contains the entire CUDA thing. Uh-huh. Okay, let's not refer functions directly from here. There are many like exponentially advanced stuff here right now. I think we should leverage GPT to give me like simple functions to explore and then we can just climb up the hierarchy of difficulty. Ah, I should free memory right now. I can free. How you free? Uh, Basically you pass uh, CUDA free. It's there. Let's say this function. Parameter device pointer to memory to free. Like you give it the memory location inside GPU, which it needs to empty. The memory address, this function text should be of inside the GPU wala memory address, not the host memory address. Okay, let's try something out. Let's make the memory usage significant so that I can notice. So let's make it 1,000 or 10,000. It will be like it's still 431. How come this can happen? It's still 430. Doesn't make any sense actually. Hmm? No, like yesterday it was like actually working how we expected it to work. Like if I multiply 10 power like 3 with one byte, let's multiply this. Yeah, bigger number. I just we should allocate in like megabytes, like in 6 terms. It is 1, 2, 3, 4, 5, 6, 7. Now it makes sense. Now I can see those. Like okay, we have like allocated around like 469 minus 431. 469 minus 431, which is 8, which is 3. So 38, uh, 38, uh, what do you call that? It's maybe bytes. 38 MIBs have allocated more right now by doing this stuff. Then I'll free up memory, then I'll print this thing. Okay, let's call CUDA. It takes only this thing. Takes simply first and repeat, yeah, nothing else. Again, call these two things. No, these two things. It frees up memory. So what CUDA free functions takes as an argument? It takes the memory location, which the CUDA malloc had returned me in the past. This function returned me a memory address of the GPU where this memory is allocated, the space is allocated. This is the address of this space. Now the address of this space is in GPU. That address is taken as the parameter by the CUDA free function, which frees up the memory. So these are the most basic function like of CUDA. One is allocating memory using CUDA malloc and freeing up memory using CUDA free. This is like analogous to using C malloc and free functions in C is also there. We have this. Oh, are the parameters it takes. One param memory address of the uh, GPU, uh, which you want to use. That's all. This will give you an error. If you do this, it will give you an error. It will give you a grave error. See what kind of error it gives. See, it doesn't act. The memory doesn't get free because I give the memory address. Which address I gave? I gave the address, the size of which associated space is 4 bytes, is 8 bytes because this is a variable of pointer type which is defined in my CPU. But the memory address it stored belongs to the space allocated in GPU, which is of 30, 40. maybe bytes, whatever it was. Now it will get free. So that's the beauty. Nice. Okay, that's it is giving me an error actually. That side is red here. The status code is not like zero. It is one. That's why it is red. I didn't notice that before, by the way. Clear it out. So there are four functions. Let's write it step by step. It is CUDA malloc, CUDA mem get info, and CUDA free. These are the four basic functions we are done with right now. We'll explore more functions as we go on learning CUDA. Okay, nice. Size underscore t is actually uh, means unsigned integer data type. Like int is signed integer and size underscore t is unsigned integer. The format specifier for unsigned integer is percentage %u, and for long unsigned integer is percentage %lu. So that's what the format is. I guess we are done with today's live stream. We explored CUDA free, CUDA memgetinfo, CUDA malloc. In the upcoming time, we'll explore more functions. Let's have a look. What are the immediate functions we'll explore in the next stream? Like we have done with CUDA malloc, CUDA free, CUDA malloc managed. This one, this unified memory stuff, which is like a lazy allocation of memory. You only allocate memory just before you use it. Uh, a host alloc allocates pinned page logged host memory. Like this is a concept of pagination, I guess. CUDA free host frees pinned host memory. Like pinned host memory. These two things revolve around that. Hmm. So this is memory allocation and deallocation. CUDA malloc, CUDA free, CUDA malloc managed. This four functions. Then I think in the next stream we'll explore some memory transfer functions. One is CUDA memcpy and copies memory between host and device. I guess this would be like much useful. Like these are the parameters taken by this function, and you have this what do you call this? It's a CUDA memcpy async. It's an asynchronous memory copy and memset, setting the value of the memory allocated in GPU. So these are the like three function we'll explore in the next trip. And then we have memory management and querying. Okay, okay, okay. Bye guys. In the next stream we'll see. Bye. We have streamed for around like 1 or 20 minutes.